next problem on Leibniz theorem. If y is cos m sin inverse x, then show that this. Okay, so y is m sin inverse x. So differentiate with respect to x. So y1 is equal to minus derivative of cos x is minus sin x. So derivative of cos m into sin inverse x is minus sin m into sin inverse x into derivative of m into sin inverse x is m constant, and the derivative of sin inverse x is 1 by root 1 minus m square, 1 minus x square. Then shift this 1 minus x square to LHS, and by squaring we can also solve this example, or again differentiate with respect to x. Without squaring we again differentiate. So u into v rule. So u into v rule, or u 1 root 1 minus x square, derivative of y1 is y2 plus y1 now as it is, and the derivative of this quantity root 1 minus x square is what? 1 by 2 times root 1 minus x square into derivative of 1 minus x square is minus 2x is equal to the derivative of now minus m is now constant, and derivative of sin m sin inverse x is cos m sin inverse x into derivative of m sin inverse x is what? M as constant, and derivative of sin inverse x is 1 by root 1 minus x square. Then multiplying throughout by root 1 minus x square. So we have 1 minus x square y2, and this root 1 minus x square and into root 1 minus x square get cancelled, and 2 to get cancelled. So we have minus x y1 is equal to this root get cancelled, and this m and this m becomes m square minus m square, and then cos m into sin inverse x, this quantity is y. So we have m y minus m y square at this place, and shifting to LHS we have plus m y square, m square y is equal to, this is m square y minus m square y. After shifting it to LHS we have plus m square y is equal to 0. And so this is the equation 1 or equation star. Now differentiate this equation star n times using Leibniz theorem we get. So we have to use the Leibniz theorem. What is the Leibniz theorem? The first term is nc0, that is 1, un, this is u now, y2 is u, and 1 minus x square is v. So y2 is continuously differentiable function, while 1 minus x square is not continuously differentiable function. So denote the continuous differentiable function by u, and this 1 minus x square as v, and then apply the apply the Leibniz theorem. So what is first term is what? nc0, that is 1, un, that is the derivative of y2, nth order derivative of y2 is yn plus 2 into v as it is, plus next term is nc1, its value is n, un minus 1, that is the derivative of n minus 1th order of u, that is the derivative of y2 of n minus 1 order, that is 2 plus n minus 1, that is n plus 1, yn plus 1. This is the n minus 1th order derivative of y2, this yn plus 1 means, into v1 means what? Derivative of minus 1 minus x square is minus 2x, plus next term is nc2, its value is n minus 1 by 2 factorial means 2, into un minus 2 means derivative of nth order of y2, and it is what? yn, and derivative of second v2 means the derivative of this 1 minus x square of second order. Its first order is minus 2x, second order is minus 2. And the next term is what? nc3 un minus 3 v3, and that v3 is 0 because the derivative of 1 minus x square of third order is 0, and so the remaining terms are 0. So this first term, this is second term, and this is third term. These three terms are the nth order derivative of this 1 minus x square y2 by using Leibniz theorem. Minus again use the Leibniz theorem to find the nth order derivative of x y1. So in bracket, right, minus in bracket, again this y1 is u, x is v, and the first term is nc0, that is 1, un means derivative of y1 of nth order is yn plus 1 into v as it is, plus next term is nc1, that is value is n, and then un minus 1 means the n minus 1th order derivative of y1. So what? Y1. So y1 means 1 plus n minus 1 is yn. So this is the nth order. Yn is what? N minus 1th order derivative of y1 into v1. V1 means derivative of x is 1. And the next term is contains v2 and v2 is 0, therefore the remaining terms are 0. So these two terms are the nth order derivative of this xy1 plus m square, and derivative of y of nth order is yn is equal to 0. So simplify this, 1 minus x square yn plus 2 minus 2nx yn plus 1, then 2 to get cancelled, n minus 1 yn, and minus sign, minus x yn plus 1 minus n yn plus n square y is equal to 0. Now collect the terms, this term as it is, and that if you find the terms, x yn plus 1, and this is x yn plus 1. Take x yn plus 1 common, minus sign common, so we have 2n plus 1 in bracket, plus the simply take yn common from these two terms, and what we have, minus n square plus n plus m square. Okay, so what we have, yn, terms of yn, and this minus n, so plus n and minus n get cancelled, so we have m square minus n square as the coefficient of yn. Okay, so these three terms, yn and yn, take yn common, we have this m square minus n square yn. That is why I have to show. So x is equal to tan log y. So x is tan log y. So tan, shift the tan to LHS, tan inverse y is log y. That is log y is tan inverse x, and y is e raised to tan inverse x. And then differentiate with respect to x. y1 e raised to tan inverse x, derivative is e raised to tan inverse x into derivative of tan inverse x is 1 by 1 plus x square. Then shift this 1 by 1 plus x square to LHS. E raised to tan inverse x is y. So we have the equation 1 plus x square y1 minus y is equal to 0. So if you observe, the n plus 1th order derivative is highest order derivative, and so differentiate 1 times and then apply the Leibniz rule. In the previous example, yn plus 1, yn plus 2 is the term. That is, it is the n plus 2 order derivative, and so differentiate 2 times and then apply Leibniz theorem. So here differentiate 1 times and then apply Leibniz theorem. So this is the star equation star. Then differentiate this equation n times using Leibniz theorem we get. So derivative of this term 1 plus x square into y1. So y1 is u, 1 plus x square is v. So first term is nc0, that is 1. un means derivative of y1 of nth order is yn plus 1. 1 plus x square as it is, v as it is, plus next term nc1, that is n. y1, derivative of y1 of n minus 1th order is yn. v1 is 2x. Then n minus 1 by 2, that is nc2 value. Then derivative of y1 of n minus 2 order is yn minus 1. And the derivative of v2 means the derivative of second order derivative of 1 plus x square is 2. And the remaining terms are 0. Minus yn, derivative of y of nth order is equal to 0. Then cancel the 2 and adjust the terms, this term as it is. Then this is 2 and xyn, and this is the 2 to get cancelled, n minus 1 yn minus 1 minus yn. Take yn common from these two terms. We have 2nx minus 1 yn plus n minus 1 yn minus 1. And that is what I have to prove. So next is, if y is y raised to 1 by m plus y raised to minus 1 by m is equal to 2x, then show that this. So y raised to 1 by m and y raised to minus 1 by m means 1 by y raised to 1 by m is equal to 2x. Take y raised to 1 by m as t. So we have t plus 1 by t is equal to 2x, and then multiplying by t, we have 2 t square plus 1 is equal to 2xt. Then shifting 2xt to LHS, we have t square minus 2xt plus 1 is equal to 0. And this is the quadratic equation in t, like the ax square plus bx plus c is equal to 0. That is the quadratic equation. And so after solving this for t, we have t is equal to, so what is the formula? Minus b plus minus root b square minus 4ac divided by 2a. We have t is equal to x plus minus root x square minus 1. We have, by using that formula, minus b, that is plus 2x plus in root b square means 4x square minus 2ac is minus 2, then take 2 as common, divide by 2, and then take 2 common, and then cancel the 2. We have x t is equal to x plus minus root x square minus 1. Take any one value, negative sign, ignore the negative sign. We have t is equal to x plus root x square minus 1, and t means y raised to 1 by m. And so y is what? X plus, taking mth power of both sides, y is equal to x plus root x square minus 1 raised to m. So in this, if you observe the previous problems, y is given. So here is y is not given, so y is this. If x is tan inverse y, we have y as e raised to tan inverse x. So if you observe the examples here, y is equal to sin inverse x bracket square. So y is given. So here y is not given. So after simplification of this equation, we have y as x plus root x square minus 1 raised to m. And now we have to differentiate, we have to prove this. If you observe the highest order derivative is of order n plus 2. So we have to differentiate this equation 2 times. This equation 1 2 times with respect to x. And then we have to apply the Leibniz theorem. So differentiate 1 with respect to x. So y1 is equal to derivative of y as y1 is equal to m x plus root x square minus 1 raised to m minus 1 into derivative of x plus root x square minus 1 is what? Derivative of x is 1 plus derivative of root x square minus 1 is 1 by 2 times root x square minus 1 into 2x. Derivative of x square minus 1 is 2x. 2 get cancelled. So we have this x by root x square minus 1. And then take root x square minus 1 as LCM. So we have root x square minus 1 plus x. That is this term. Okay. And x plus root x square minus 1 into this term x plus root x square minus 1 raised to 1 is x plus root x square minus 1 raised to m minus 1 plus 1. The same addition of power. So we have raised to m. So the term x plus root x square minus 1 raised to m minus 1 and raised to 1 is raised to m minus 1 plus 1 means raised to m divided by root x square minus 1. And that is, this term is what? X plus root x square minus 1 raised to m is y. So now add this y. Then shift this term root x square minus 1 to LHS. We have root x square minus 1 y1 is equal to my. Differentiate 1 seconds because we have to differentiate this 2 times. So u into v rule, root x square minus 1, derivative of y1 is y2 plus y1. Root x square minus 1, derivative is 1 by 2 times root x square minus 1 into 2x. Derivative of x square is 2. 2 to get cancelled, we have this term. It's equal to m y1, derivative of this quantity. M y1. And what is y1? M y1. And then what is y1? Y1 is this my divided by root x square minus 1. This is y. Then multiplying by root x square minus 1. So we have x square minus 1 y2 plus x y1 minus m square y. M square y. This m into m square y. Root x square minus 1 get cancelled. And now we have to differentiate this with respect to x. So adjust this m y1, adjust this, or squaring both sides. Squaring at this place, and then simplify by dividing 2y1 we have this. If there is a square root, then squaring both sides and then apply the next order derivative. So now differentiate this second n times using Leibniz theorem. We get nc0 is 1. un means derivative of y2 of nth order is yn plus 2 x square minus 1 v as it is plus nc1 value is n, y2 derivative of y2 of nth order n minus 1th order is yn plus 1 2x derivative of x square minus 1 as 2x v1 plus nc2 value is n minus 1 by 2 factorial, that is 2 un minus 2 is yn into derivative of x square minus 2 of second order v2 as 2, and the remaining terms are 0. Then x y1, that terms are yn plus 1x plus n yn by Leibniz theorem. yn plus 1. Derivative of un y1 is what? Yn plus 1. Yn plus 1. So what? Yes, yn plus 1 x plus ny is this term is correct. Ny into 1 ny dot 1 into 1 minus m square yn derivative of y is equal to 0. Then this term as it is, 2 to get cancelled, yn plus 2, the remaining terms, and then take x yn plus 1 as common from these two terms, x yn plus 1, and this is x yn plus 1, so 2n plus 1 in bracket, plus the remaining terms are yn, take yn as common, so n square minus n plus n minus n plus n 0 minus m square, so n square minus m square yn is equal to. Same type example, cos inverse y by b is equal to log x by n raised to n, then show that this. So cos inverse y by b is equal to log x by n raised to n. So cos inverse y by b is equal to, this is log a raised to m, n log x by n, and log a by b rule. Then differentiate. So derivative of cos inverse y by is minus 1 by root 1 minus y square by b square into derivative of y by b is y1 by b is equal to n log x derivative is 1 by x minus log n derivative is 0. So y1, this simplification, root divided by b square is LCM, b square minus y square. So we have root b square as LCM, then root b square minus y square, and then root b square minus y square as divided by b, and then multiply by b divided by root b square minus y square. B get cancelled, so y1, and then taking square root of both sides. So we have y1 square x square is equal to n square b square minus y square. I can differentiate with respect to x. So u into v rule, derivative of y1 square is 2y1 into y2, x square as it is, and now x square, derivative of x square is 2x, y1 square as it is equal to n square is now constant, b square derivative is 0 minus y square derivative is minus 2y into y1. So we have this term. After shifting this to the LHS and by dividing 2y1, we have this, and then apply Leibniz theorem. Differentiate this equation n times using Leibniz theorem. So we have un plus un term y2 derivative of y2 of nth order is yn plus 2, v1 v as it is, not v1, v plus next term nc1, that is n un plus 1 derivative of y2 of n un minus 1 un minus 1 is y, yeah, yn plus 1, v1 is 2x, then n minus 1 by 2 factorial, y2 the derivative of u, this y2 as u, un minus 2 is yn into the second order derivative v2 is 2 and the remaining terms are 0, then xy1, that these two terms are the nth order derivative of xy1 plus n square yn derivative of y as yn is equal to 0, and then cancel these two and then collect the terms of xyn plus 1 and yn, we have this. Okay, these are the examples for homework. Y is equal to sin inverse x divided by root 1 minus x square. So shift this root 1 minus x square to LHS, squaring both sides, and then solve. Then solve the equation. This differentiate 2 times. E raised to tan inverse x. We have to prove this. So we have to prove this. Y is e raised to tan inverse x. Now we have to differentiate this 2 times now. If you observe this example, e raised to x into log tan y. Actually, it is after simplification, we have y is equal to e raised to tan inverse x. But what is we have to prove here? We have to prove yn plus 1 is the highest order derivative. So differentiate this y e raised to tan inverse x 1 times and then apply Leibniz theorem. You had now in the exercise problem, we have to differentiate this equation second against 1 time. That is differentiate this 1 plus x square y1 minus y with respect to x. We have 1 plus x square y2 plus twice x y1 minus y1 is equal to 0, and that is the equation number 3, and then apply the Leibniz theorem. So in order to solve this problem, first y is equal to e raised to tan inverse x, then we have to show this. Here if you observe yn plus 2 is the highest order derivative. So differentiate this y is equal to e raised to tan inverse 2 times and then apply Leibniz theorem. Y is equal to tan inverse x, then we have to prove this. Again differentiate this y is equal to tan inverse x 2 times and then apply Leibniz theorem. Y is equal to sin inverse x, differentiate 2 times and then apply Leibniz theorem. Here y is a cos log x plus b sin log x, again differentiate 2 times and then apply Leibniz theorem. This problem is also of the same type. Y is the log x plus root x square plus x square bracket square, and so log a raised to m is 2 log a. First apply that rule, 2 log a, 2 log x plus root a square minus x square, and then differentiate 2 times and then apply Leibniz theorem. We have this. So these are the some problems. These are the some summary of the chapter, that 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 1 raised to infinity, 0 raised to 0, infinite raised to 0 are all indeterminate forms. So these are useful summary for fill in the blanks or MCQ questions. Y is ax plus b raised to m, then yn is this. Y is 1 by ax plus b, then yn is this. So these are the 9 formulas of the nth order derivative. We have already the proof of these 9 formulas and the problems on the 9 problems. This is the Leibniz theorem. So statement of the Leibniz theorem is important. Taylor's theorem, the statement of Taylor's theorem is important. Similarly, the Maclaurin's theorem is also important. Statement of Maclaurin's theorem. So these are the summary, and these are the 2 true false. If limit of fx is 0 and limit of gx is 1, then these 2 are equal is not possible. So because the these are on the LHospital Rule. So this is true statement, third statement is true. Similarly, this is on the rule. So fill in the blanks. Which of the following is indeterminate form? So infinity raised to 0, 1 raised to 0, infinity plus infinity. So the answer is what? 1 raised to 0 is an indeterminate form. So if you observe the indeterminate form, these are the indeterminate forms. These are the indeterminate forms. 1 raised to infinity, 0 raised to infinite raised to 0. So this answer is wrong. 1 raised to 0 is determined form. Infinite raised to 0. This is the indeterminate form. This answer is wrong. So we have to find the this limit by using LHospital Rule. X raised to x, answer is 1, limit of x raised to x. So similarly, the remaining problems. So write all these problems in your notebook. So if y is x raised to m, then what is yn? Then yn is 0 if, when yn is 0, that is if n is greater than m. That is the, if you find derivative of y is equal to x square. So what is the derivative of x square of the second order? The first order is 2x and the second order is 2 and the third order is 0. So if n is greater than m, then we have yn is 0. Similarly, this is the fill in the blanks on a MCQ type question on nth order derivative of the function sin ax plus b. We know the derivative of sin m. So this is the on Leibniz theorem. This is again on the nth order derivative. So this is the nth order derivative, 1 divided by ax plus b formula. This is the formula. Okay. So this, write all these MCQ in your notebook and solve these exercise problems in your assignment notebook. So we will see the next chapter, differential equation, in the next lecture.